Here we have the infinite series 1 divided by n factorial, and we want to use the direct comparison test to show that this series converges. And this is the direct comparison test, and to use the direct comparison test, we have to come up with a series B sub n. And we have to show two things: that the series A sub n, which is the given series, is less than or equal to the series B sub n. And then we also have to show that the series B sub n converges. So let's call 1 over n factorial, let's call it A sub n, and then let B sub n be 0.9 to the n. And the reason we choose 0.9 to the n here, because we know something about this series. This is a geometric series with common ratio of 0.9. And we know that for geometric series, if the common ratio is between -1 and 1, then the series converges. And so that's why we choose the 0.9 to the n. And now let's compare 1 over n factorial with 0.9 to the n. When n is 1, this is A sub n right here. This is A. And this is B sub n. When n is 1, then A sub n is 1, B sub n is 0.9. So A sub n is greater than B sub n. When n is 2, A sub n is 0.5 and B sub n is 0.81. And when n is 3, this is about 0.16666, and this is 0.729. And here's the first 10 terms. And so we can see that with the exception of when n is 1, then A sub n is greater than B sub n. But from 2 on, when n is 2 or more, then A sub n is less than B sub n. And the sum of the first 10 terms for A sub n is 1.7828A18. But the sum of the first 10 terms for the series B sub n is 5.86. And so when we compare the first 10 terms of the series A sub n with the series B sub n, then we can see that the series A sub n is less than the series B sub n for the first 10 terms. But from term number 11 on, A sub n is less than B sub n. And therefore we can say that the series 1 over n factorial is less than the series 0.9 to the n. And so we have shown the first part right here, that the series A sub n is less than the series B sub n. And then now we need to show that the series B sub n converges. So we need to show that the series B sub n here converges. B sub n is a geometric series with common ratio R is between -1 and 1. And for geometric series, we know that if the common ratio is between -1 and 1, the series converges. By geometric series test. Therefore, the series 1 over n factorial converges by direct comparison test. So once again, to use the direct comparison test, we have to show two things: that the series a sub n is less than the series b sub n. And we also have to show that the series b sub n converges. And we have shown two things. We have shown both. And the logic behind the direct comparison test, notice that this is a positive series, meaning that it's always greater than 0. And we have just shown that this series converges, meaning it's equal to some real finite number, which means that this series is bounded between 0 and some real finite number. And because it's a positive series, it's also monotonic, and therefore it converges. And so that's the logic behind the direct comparison test. But once again, to use the direct comparison test, we have to come up with a series b sub n, and then show that the series a sub n is less than the series b sub n, and the series b sub n converges.